Hi, in this video I'm going to talk about a key concept and the concept is of covariance and contravariance. And I will be talking about these concepts in relation to generics. And I'm using Java as a programming language to demonstrate the concept with some examples. I will also be comparing very briefly arrays with generics. So let's start with what covariance is. So covariance and to give you an example, let's assume that T is a type which is a parent type and there is a subtype S extends T. So the concept of covariance is that T can accept the value of subtype S, and that is covariance. And in terms of arrays are covariant because array of type T can store array of subtype S. Example here is you have an integer array, you add some values into it, and then you define a number array. Integer extends number, so integer is subtype of number, and you can assign a new object of number to accept an integer array. And that is why uh, arrays are covariant because the parent type, the supertype, can accept the subtypes. So this code will build well and will run without a problem. So here it runs, and let me just give some space to the window here. So there are a bunch of print statements in my code which I will come to later. So that's the concepts of covariance and why arrays are covariant or how they are covariant. Another key thing with the arrays is that they are refied, which means the element type gets checked at runtime. And to demonstrate that, let's have an object array, and it is created as an integer array here. The type is object, and the object assigned is of integer here, and you assign it a float value. So build does not give you any problem. It does not tell you that there is a problem. But when you run it, that's where you get to know the error. And that's how it demonstrates you that the element type is checked at runtime. At runtime, it sees that the actual type of this object is an integer array, and you are assigning a float value to it. So that's incorrect. You get it back to integer, and it will work without any problem. Let's move on. Let's move on to generics. Generics are invariant, which means that you cannot store subtype S in type T. It will give you a compile time error. So that's better than arrays, because otherwise you will come to know about error at runtime. Here you are knowing that error at compile time, which makes the program better because as a programmer you would know about it and you would fix the problem. So let's see. You have an integer array, integer list, sorry, and then you add an integer here, list. Do the same thing for a list here. You have a number list and you are assigning an integer list to it. So straight away, even without compiling, the IDE is telling you that there is a problem. And the problem here is it says, change variable my list float type to list integer. So it is checking at compile time itself and not allowing you to store subtype, which is integer, into the supertype of number. So let's just comment this code and let's move on to the next section here. Enabling covariance in generics takes a little bit of effort. You have to define a list in a particular manner. In this example, what I'm doing is that I'm defining a list with this question mark as a character. I extend it with number and I'm assigning an array list float. I have some default bunch of float values up here, and by doing that, this list is now unable to read subtype elements. I could have, an array list of integer up here and it will not give me an error. But I emphasized on read because this type of list does not allow you to add any element into it. And I will come to the reason for that, but let me just first show you the error. So you will see this error up here, and it is telling you that you should mention the list as float. And why it is giving you an error? Because the compiler is not able to determine the actual type of the object that can be stored in this generic list. And the reason for that is that number has different subtypes. So compiler can't make it out that which actual type of the object is there in the generic structure, and that is why it is giving you an error up here. Let me just comment it for a moment. And but what about adding elements into a list which are not of the type that you would define, that you defined earlier in the program? And for that there is contravariance that comes handy for generics. What contravariance is, it is the opposite of covariance. And in this example, what I'm doing is I'm defining a list. I have a different keyword here, which is super. So super number, and my objs is my object name up here, the list object name. And I'm defining it an array list of object. So the super number list here can accept super type, which means that it can accept the object type of objects. Earlier, in the concept of covariance, the supertype was accepting subtypes, and in the contravariance, the type is accepting supertypes, and that is why it is called contravariance, because it accepts supertypes. And in the code up here, you see, this list I'm defining as an object. I'm adding a float value up here, no problem with that. And then I'm adding, the my numstat get 0, the element from the other list. So I could do that, and then I'm just printing it out. So by having the covariance and contravariance, you can enable or use polymorphism with generic lists as well. That is the end of my video. Do let me know if you have any questions for me, and I would like to learn from you or help answer your questions. Thank you very much.